Hello, my dear lovely students. Good evening to all. I'm Ritesh Misra. I welcome you on this YouTube channel. Today we are going to study EI reactions. EI, sin elimination reactions. In the last video lecture, we have done Hofmann elimination reactions. That was a part of beta elimination reactions. So, students, let's start the EI eliminations. EI, intramolecular elimination reactions. Elimination reactions. Students, it is a part of beta elimination reactions. It is a part of beta eliminations. As you remember, beta eliminations is a 1-2 eliminations. So there is a one eliminations is a syn elimination, which is called EI, and second is anti-elimination, which may be E1, E2, E1CB, which will be the set GIF and Hofmann. So we are going to understand the syn eliminations, EI eliminations, right? Students, EI eliminations is pyrolytic eliminations. Pyrolytic eliminations. Pyrolytic means what? When we supply the simply temperature, that reaction will favor. No inert gas, no solvent, no base, no acid will require for EI reaction. So simply when we supply the temperature, their elimination will take place. Okay. So what I'm telling you that which substances will favor the syn eliminations? Student, the substances is either amine, oxide, ester, xanthate, or halide. These substances will favor syn eliminations. That means EI eliminations. These substances will favor EI eliminations. Okay. Now, what I'm telling you, there's some criteria, some conditions for EI reactions. The one is, as you know, since it is a part of beta eliminations reaction, so first condition that it should be beta hydrogen atom, and that should be the acidic, and that should be the acidic hydrogens. Second part is either it will form, I'm talking about EI, either it will form cyclic 5-member or 6-member ring transition state. Student, that transition state, 5 or 6-member cyclic transition state is called pericyclic transition state. Next part is, that is the syn eliminations. I have written syn eliminations means both two atoms, those two atoms will remove, that will be on the same side. So I write here, means elimination will take places from the same side. That means eliminations should takes place from same side. Okay. Okay. Let's understand the EI one reaction is co-elimination reactions. Okay. So understand the co-eliminations. Students, co-eliminations will be when you have tertiary amine oxide and oxide, when hydroxyl amine. Okay. So now we understand here through example. Student, we have CH3, CH, H, CH2, and methyl CH3O negative, which is the negative charge, which is the base strength. So it will attack obviously on the acidic hydrogens, and you know beta positions is the highly acidic positions. Here is the positive charge. So it will attack the beta positions, hydrogens, and take the electron from the carbon, so that the carbon will contain the negative charge because it will give the electrons. Okay. So once the compound contains negative charge, here is the nitrogen, which is the highly reactive, more inductive effect here, minus I effect. So it will take the electrons. As a result, positive charge will come here. And your question, sir, why I have written like these substances? Actually, you can observe here, hydrogen and this group are on the same side, not in the opposite side. Okay. So we have to keep in mind when both the groups should be in the same side. As a result, here the negative charge, here the positive charge. So CH3, CH double bond CH2 will form plus HO. So HO and CH3, CH3 will form. This is called hydroxyl amine. Okay. So did you observe one thing here? Nitrogens and hydrogens, hydrogen and Ne2 I have written in the same side. So hydrogen and NMe2 must lie on the same side. Right? Okay. Now we understand through many more. One example is here. One compounds and CH3, CH3O negative. Student, you can observe here, here is the alpha, here is the beta. So now this beta positions as hydrogens. So now oxygen will attack on these hydrogens. As a result, here is negative charge will come. Once the negative charge on this ring will come, nitrogen will take up the electrons and here positive charge will come. So the double bond will form plus H, O, and CH3, CH3. Correct? One more example, students. Here is CH3, CH2, and CH3, CH3O negative charge is there. Again, alpha, beta. So oxygen will attack on these two hydrogens, which are the three hydrogens. So I write either two hydrogen and one hydrogen like that. So it will attack here. As a result, what happened? Negative charge will come, will take the electron, and then CH2 double bond CH2 will form. Correct? Plus HO and CH3 all 2. One more example, students. See here that okay, and here is the CH2 and oxygen's negative charge CH3, CH3. So what will happen? Again, here is alpha, it is a beta, it is a hydrogen, so it is beta hydrogen. Oxygen will attack here, so negative charge will come, that bond will break here, and as a result, the compound will form like that CH2. Am I right? One more example. Here is uh, I write the cyclopentane like that. 1, 2, 3, 4, 5. Okay. So N CH3, CH3, O negative. Here is the hydrogens, deuterium hydrogens. Keep in mind, students, the question is, which will remove, sir, deuterium or hydrogens? Students, see that deuterium and these compounds, third butoxide, are in the same plane. So therefore, oxygen will attack on the deuterium, not on the hydrogens. Is placed in a seed of deuterium, then of course the the hydrogen. But here is deuterium and oxygen on the same plane, therefore it will attack on the deuterium. And here's the negative charge will come, okay? And since the negative charge will come, because it is alpha, it is a beta. So that bond will break here and 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This compound will form, correct? Now, my one important question is here. My dear students, can you tell me this compound will form, that compound will go into that cope elimination or not? Here is. You can observe here. Student, this type of compound will not, cyclic member ring will not involve in the cope eliminations. You know why? Because already it is a planar structure, almost planar. It is almost in planar structure. So in the cope elimination, the transition state is a planar structure. Since it is already in the planar, how it will go into the planar structure? So therefore, this type of compound, yes, but if you have a 7 member or 8 member ring, definitely that will go into the cope elimination reactions. Okay. Now, one thing you can ask me here. What the question is, sir, how we can prepare the tertiary amine oxide? Is it right or not? How you can prepare the tertiary amine oxide? Student, simply nitrogen is here, and I write the R dash and R double dash. If you have a HO means I have taken that H2O2. Now lone pair will attack here on the oxygen, that will turn here. So that what will happen? And R dash, R double dash, OH. Now you have OH negative, because here is that will attack on these hydrogens and it will form O negative, R dash, R double dash. Did you understand? So this is the logic strength of cope eliminations. Next video we will have pyrolysis of ester, that is also part of EI reactions. Students, have you got that? All these points? If yes, please subscribe, like, and share the channel, which motivate me to make a more video for you. Thank you. Have a nice day.